Recording in progress. Progress.
Good morning, everyone. My name is Stephen Vitale. I've been a professional engineer now for over 50 years, and I've seen a lot of experience. I have 52 years of engineering experience in the gas industry, and I left the gas industry, a particular company, in 2004. And for the last 20 years, I've been doing freelance consulting. In doing that, I've gotten a lot of experience of different cultures and different modes of operating across the world and across the country. And I've seen many situations where ethics became an issue, where knowledge base became an issue, and where there have been situations that many of which I will explain to you. This course is going to take two major directions. One is I'm going to give you the theory, and the theory being what the National Professional Society of Engineers dictates as their code of conduct, what the National Council of Engineer Examiners of Engineering and Science and Surveys give as their code of ethics, and what ABET, the Accreditation Board for Engineers and Technology, what they say about ethics. So you'll see the first part of it being very much like, here's the information as it is written. And then the second part of it will be a lot of practical, real life scenarios that I've lived through and that I know firsthand. I wouldn't be putting them here if I didn't know of them firsthand. So let's talk about the professional engineer. The professional engineer, I define two things here. The word professional. Professional means adheres to ethical standards, demonstrates competence in their field, and is committed to continuous improvement. They maintain a high level of responsibility, accountability, and integrity in their work, often regulated by professional organizations or codes of conduct. And what is integrity? A man who walks with integrity, is unwavering in his principles, acts with honesty and fairness, and earns the trust and respect of others. He does this through consistent ethical behavior. And I mentioned consistent ethical behavior because I want you to I want to put out a word picture for you. Picture yourself standing on the top of a large dome. And the dome, of course, because the dome is shaped like a sphere, and then at the center, it's got the mini section of the sphere, the diameter of the sphere, and that's sitting on the ground, and it's covered with ice, and you are standing right on the top of that dome. Once you go a little bit off the center, it's very easy to go down a slippery slope down to the bottom. And I bring that up because there are many times where there'll be pressures on you to deviate from your ethics and just a little bit. But then the next time it gets a little bit easier to do that, but the consequences become higher and a little easier, and the consequences become higher. And then eventually you're looking up and saying, how did I ever get into this situation? So I just wanted to mention that because it's the word picture I have in my head when I think of ethics in engineering. The preamble to the National Society of Professional Engineers Ethics Code is engineering is a profession that directly impacts the quality of life for all people. Engineers must exhibit the highest standards of honesty, integrity, and dedication to protecting the public health, safety, and welfare. And if I had to summarize everything I'm going to be saying today, it comes down to two. Unfortunately, I have the timer on this, but I'm going to have to deal with it. It's better listen to my timing, not its timing. It deals with two issues, and one is you as engineers protecting the safety, the health, and the welfare of the public, and also you following your moral compass, doing what is right in your engineering practice. We'll get into examples of that. The fundamental canons of the National Society of Professional Engineers outlines 6 fundamental canons. They are: 1, to hold paramount the safety, health, and welfare of the public. 2, to perform services only in areas of your competence. 3, to issue public statements truthfully. 4, to act as faithful agents to your clients. You may ask, who's your clients? Well, that would be your boss, your customer, and anyone you deal with including vendors and even contractors who work for you. Those are all your clients, and you need to be faithful agents of those. I'm going to see if I can stop the automatic narrations on here and do that. And we'll go to transitions. Nope. Animation. Nope. Slideshow. And use timings. Show me the control. Let me see if that helps. Okay, so you're going to act as faithful agents to your clients. You're going to avoid deceptive acts, and we'll certainly discuss quite a few of those. And work in a conduct that enhances the honor and reputation of your profession. So even if during your profession while you're at work, you are doing everything ethically, everything by the book, you also have to, while you're off the clock, be an ethical person, because you are representing your professional engineer. You're known as a professional engineer, and as such, you cannot be doing racketeering as your night job and professional engineering as your day job. I pick racketeering because that's an extreme. The rule of practice 1, public safety, and this is probably the most important one because it just stands out there as paramount. Engineers must hold paramount the safety, health, and welfare of the public. If in their judgment is overruled, if their judgment is overruled in any way that endangers life, property, they must notify their employee or relevant authorities. Now, this is a very sensitive one because what it really means is that if you know that what your company is doing is endangering the life and property of the public, and your employer says to you, or your boss says to you, just keep quiet about it, just leave it be. It's a decision we made. You have an obligation to go to a higher authority. And I know it's very difficult. And I know there are times where it's cost me perhaps promotion or move upward mobility in my company. But I look back and I don't regret a single time that had to be done. And we'll explain some of those as we go along. Rule of practice number 2, competence. Engineers must only perform services in their area of competence. They cannot sign off on work that they are not qualified or did not supervise directly. And think about what happens. So now you're promoted to now be manager over engineering, and you find out that the manager of engineering is required to stamp all the drawings that come out of his area. And you get a mechanical engineering drawing, and you did oversee and supervise that, and you look at it and you stamp it. And then you get an instrumentation drawing, and you say, I know nothing about instrumentation, nothing substantial about instrumentation, and this looks like a chicken walked across the page. Can I really stamp this? The answer is no. So you need to now get the person who did that work to stamp that drawing. But what if the person who did that work is not a professional engineer? You need to hire a professional engineer or hire a consultant to come in and review that work and stamp it. Now, that's a little bit tough for the new manager who just got promoted into this job. He's grateful he got promoted, and now he's in a position where he's upsetting everyone up at higher levels because he says, I cannot stamp these drawings if I don't know what they're saying. And that's the way it is. You cannot. Rule of practice number 3, public statements. Engineers must make public statements that are objective and truthful. They should provide relevant information in reports and testimony and avoid misleading statements. And here I caution you because sometimes an untruthful statement can be a statement that is never said. It's a very interesting thing. It's also deceiving by withholding information. So when you're giving public statements, you must make them truthful and give all of the information that should be given so that you are communicating truthfully. I'll give you, for instance, that did happen in one of my experiences. I was part of a company that took over another company. Taking over that other company, I was put in charge of engineering. So I was in charge of engineering across 5 states, and I went up to one of the states where the old company that we had just taken over was giving a presentation on the state of the union of the equipment that we dealt with. And I was listening to one of my engineers give a presentation, and I raised my hand and I said, "Have we taken care of all the low pressure areas in our territory?" And the engineer looked me straight in the face and says, "We've addressed all of the low pressure areas." And I was shocked because I said, "That's really impressive. These people have their act together because that's quite hard to do." But I was very pleased to hear that. But then after the meeting, I spoke to that engineer and I said, "We've actually addressed all of them." He said, "Oh, yeah, we have." I said, "What does the word addressed means?" And he told me, "Addressed means we know where they are." So that was an untruthful statement. You may say, well, the word is was truthful, but it was a deceptive statement. So I had to reach out to all the audience that was at that meeting and clear that up. And then I had to find out why he made that statement. And he said to me, because that's what the CEO wants to hear. And he's told me that's what he wants me to say. So then I have to deal with the CEO of that company. So I went to the CEO of that company and we went nose to nose, arguing on that you cannot do it this way. And he says, "That's the way we always do it here. We cannot publicly say that we are not prepared for the coldest days, et cetera, et cetera." So at any rate, I didn't let it go, and I got the us as being the taking over company, our president involved, and a deal was made to invest $3 million a year and invest $1 million a year for 3 years into the system and then get it up to snuff so that we could, in 3 years, say we have addressed truthfully all of the low pressure systems. Now, what was interesting in that is that exactly 3 years to that winter, we did get a peak day, a peak demand day. And because of the $3 million that we invested, we were able to get through it without any loss of gas to customers. Rule number 4, uh, faithful agents. Engineers must act on for their employees or clients as faithful agents, disclosing any potential conflicts of interest. They must not accept compensation from multiple parties unless all parties are informed. You have an obligation to, let's say you're getting uh, an income from both your engineering company and from the contractor you're working on the side for them as a consultant and helping them do the technical part of their work. You have to disclose that information. That is your requirement for being a faithful agent. And there are a number of examples that I will give you when we get to the examples part, where people have not been faithful agents, and where some people got fired actually, and disciplinary action was taken. Rule of practice number 5, avoid deceptive acts. Engineers must avoid deceptive acts such as misrepresenting qualifications or engaging in exaggerating, I should say, past accomplishments. So if you're writing your resume, you can't say I was lead engineer if you were just a supportive engineer. I was lead commissioning engineer. I was a commissioning engineer on that project. Leave the word lead out if you weren't lead. They must not engage in any form of bribery or dishonest conduct. One day, a inspector who working for me came up to me and said, "Steve, the contractor XYZ. He gave me an envelope today. I opened the envelope. It was full of $100 bills. So I gave the envelope back to him. And I said, I can't take that. And I said to him, that's a very, you did the good thing. You did the right thing. You were good as a good steward of your responsibilities. You might think, well, I did the right thing and he did the right thing. The question I ask is, did I go far enough? I should have really gone the next step and said, I got to bring this to higher authorities. Because if he's doing that to my uh, inspector, how many other inspectors is he doing that to? And we're in a company where there might have been like 30 inspectors out working for different parts of the company. So if even one inspector took that envelope, it could be problematic, very problematic. Problematic's a light word for it. Rule of practice number 6, conduct that enhances the honor and reputation of the profession. Your ethical conduct goes beyond the immediate activities of your engineering job to include other activities that could discredit your reputation and thus discredit the reputation of your profession. For example, you cannot engage in racketeering as a second job. And I picked that one because it's so extreme. But there are a lot of gray areas that you'll come across, and you have to ask yourself, am I being totally ethical in doing this? Am I respecting my profession? And you could think of it also as if you were going to a doctor for services, what kind of doctor would you want to be going to? What kind of doctor would you want to be repairing or working on your body? Professional obligation. Engineers must be guided by honesty and integrity in all professional relationships. They must acknowledge errors, avoid conflicts of interest, and treat all persons with dignity and respect. And this is an interesting one. You should think about it this way. You're doing your work and you realize I made a mistake in that calculation. It was last week. They've done so much work on this project since. Nothing's going to happen. Uh, do I have to really go back and acknowledge that error? And the fact is, yes. If you made an error in calculations, it will haunt you for the rest of your life if you don't fix that error. And you may find that error years after the fact, but you at least have to have that error evaluated to see that if it's going to affect the public safety and welfare, and if it affects it in a positive way, then it's a non-issue. But if it affects it in a negative way, let's say you find out that it doubled your factor of safety. Well, that's terrific. If it halved your factor of safety, then something has to be done. And I'll tell you a story about a building that was reviewed after the fact, and then they found out that it could not withstand the wind loading under certain conditions. And they had to re-go, and it was a skyscraper, they had to re-go into that building and put cross braces up on every floor to reinforce that building. I'll give you, for instance, take a look at the drawing that's in front of you. Now, where did this drawing come from? I generated this drawing using AI. AI has biases to it. So I had to say, hey, AI, the first drawing it gave me, they were all male engineers. I said, I want to be diverse in my presentation. I said, put some female engineers, put some different races in there as well. And then I came back with this, and this one I said acceptable. Now I still have my own biases because I'm from 52 years ago starting my engineering work. And I have to be cognizant of what those biases are and make sure that I don't have embedded biases that I bring to the job site. And if I do identify them, I have to work at getting rid of them. And it has been a constant correction, of course. And I say that because 55 years ago, this was not even on anyone's radar screen. They need to design with sustainable development. Engineers should adhere to principles of sustaining development to protect the environment for the future generations. This includes designing systems that meet human needs while conserving natural resources. We have a limited number of natural resources, and we have to be building for the generations of the future as well as for this generation. And I think about it this way. I had a close relation of mine who was interested in flipping houses. And in his wording, he said, all I want to do is make it look pretty and then sell it. And he wanted me to be of help on the engineering end. And I could have been of help on the engineering end, but I was too much of an engineer. And I said to him, no, you have to build these houses as if your daughter is living above in the top floor of that building. And we did not see eye to eye. And I said, I cannot be of any help to you. Uh, Go find yourself another architect or another engineer. But did I even go far enough with that? I did not. So then I went a step further and I confronted and counseled with him, and he opted to do the right job. It was not as uh, economically advantageous to him, so he eventually got out of that business. If you can't do it with ethics, then maybe you should not be doing it at all, was the bottom line to that. Reporting violations is a tough one. Engineers who are aware of violations of the code of ethics must report them to the appropriate authorities. Now, let's say you go to your boss and he says, okay, let's fix that. Okay, done. It is done. It is fixed. You've done the ethical thing and the corrective action has been taken. But let's say they just put it off, and you know darn well it's being ignored, and it will continue to be ignored. You are required to go up to a higher authority. And where is that higher authority? If it's in your company and the company still maintains to be putting the public at risk, you have an obligation then to go outside of your company to the proper authorities. And we'll go over a number of cases such as the Pinto case and other cases where people went outside of their company to get the attention of the regulating authorities to take action. Think about the Space Shuttle Challenger. Those engineers knew, and they said, we cannot launch under these cold temperatures. We cannot launch under these cold temperatures. And their chief engineer stood firm and said, we cannot launch under these cold temperatures. And then upper management came to the chief engineer and said, take off your engineering hat, put on your management hat, and now think again. It's a lot of pressure to be under. So he wavered and he said, okay, we'll launch, knowing well that there was a high risk of that O-ring failing. 73 seconds after liftoff, that Challenger spacecraft blew up and 7 astronauts were killed. And the damage that was done to NASA and the industry was far worse than any delay of a space shuttle. I think about it, and this happens. There was a safety video I was watching, and the person says, if you think safety is expensive, try an accident. And that stuck with me because there's some real concern there. Hold on, I have something. Please send your comments. Oh, there's in the chat box. You'll see it says, please send your comments and questions to Steve via Q&A. I've had trouble using the Q&A, so I'd rather get the questions on the chat box if possible. Okay. Case study in because of the Zoom integration. Okay, because of the Zoom, I could not see the very top line. It says case study integration guidelines and practice. And case studies, I got about 30 case studies. We won't get to all of them, but we'll get to a good number of them. In reviewing case studies such as the Challenger disaster and the Hyatt Walkway collapse, we see clear violations of professional engineering guidelines. These examples demonstrate the critical need for engineers to adhere to ethical standards. And one of the ones I'm glad that I have in here is the Hyatt walkway collapse, because a good amount of my engineering practice has been practical engineering inside petrochemical plants, where a lot of changes are made to original designs. Once you make a change to original design, you have to have it re-engineered, because if you don't, what might seem like just a simple change could be a disaster. And I'll show you with the Hyatt walkway collapse how a simple change, in fact, it seemed like a job improvement, became and indeed a disaster. Conclusion: ethical practice in engineering. Ethical practice is the cornerstone of engineering profession. Engineers must prioritize public safety and adhere to ethical standards. Those are the two that stand out: public safety, ethical standards, and commit to a lifelong professional development. By maintaining ethical integrity, engineers can ensure the trust and safety of society. Now, I'll give you a for instance that may be happening right now. You are fulfilling your responsibility right now of of doing your continuing education course. I cannot see you and you can see me. And perhaps you're doing keyboard work on another project while you're watching this course. Well, is that really fulfilling your obligation to walk with integrity as a professional engineer? That's for you to decide. Perhaps you're really brilliant and you can multitask real easily. Future trends in engineering ethics. As technology advances, engineers will face new ethical challenges, including ethical implications of artificial intelligence, cybersecurity, biotechnology. Engineers must continue to adapt and apply ethical principles to emerging fields to ensure that their work benefits society and protects the public. This picture that I put here is not so far-fetched. Now, I used AI to make this picture. I've only been using AI for about the last 3 months. It's brand new to me. I haven't scratched the surface on how to do it, but I specifically told it that I wanted a diverse workforce and I want an AI person in here because it won't be long before we have AI bots or some form of intelligent right within our work. The other day, I did a 2 hour calculation. And after doing that 2 hour calculation, I wanted to proof it. So I just went into AI, typed the problem in, and it gave me it went step by step by step, same exact steps I went through, and there was the answer. Now, I'm not saying you shouldn't use AI, but be careful. AI can make mistakes. And right now, at the present level, the present state of AI can make mistakes and it can make up data as well. So you have to be careful in your use of AI, and that's just the tip of the iceberg. Cybersecurity is another issue. You want to make sure that you are protecting when you are tying into your client's server. You want to make sure that you're protecting their data and that you're not sloppy with it. As a consultant, I get a lot of confidential data that comes in. Well, I can't just throw that in the garbage when I'm finished with it. I have to make sure it's shredded and that no and electronically I have to make sure that it's well protected. So I can't have a Hunter Biden laptop go to my repair shop. I need to make sure that when I have and I bring this computer for a repair shop, that confidential data is not present on the computer. I use Dropbox quite often, and I need to make sure that that information is secure, etc. Think about the Manhattan Project, some of the ethical issues that Oppenheimer had regarding and Einstein had regarding the production of the atomic bomb. I'm not saying it was right or wrong. I'm not taking a position on it, but it must have been a difficult, a difficult issue right now. And we are at a point right now where the entire world could be totally wiped out multiple times in a matter of minutes, hours. So I'll just say hours. But it's a thermonuclear weapons have become they're so prolific now that and they can get into wrong hands. It's a it's an issue that you as an engineer has to have an ethical posture as to whether you want to be involved in certain types of technology. And I'm not saying that pro or con. I'm just saying it that you have to make sure you're following your ethical compass. Technological advancements in ethics. The rapid advancement of AI and robotics introduces new ethical concerns. Engineers must address issues of bias and privacy, accountability when designing, implementing these technologies. Ethical decision making is critical to ensuring that technology serves the public good. Where I get very concerned here is when you start digging in data where you can get vast amounts of data and invade people's privacy. And perhaps if that gets into the wrong hands, can really be damaging to society. So it's part of what you as engineers have to be in deciding as you move along with the newer technologies. Cyber and ethics engineering. Cybersecurity becomes more critical in modern engineering practices. Engineers must take steps to protect data, ensure privacy, prevent malicious use of technology. Ethical frameworks guide responsible behavior in the digital realm. In 2020, the United States was severely attacked by malware into the government systems of the United States. And it's the ramifications of that is even carried on till today. Tremendous amount of digital information was stolen. In that particular case, they blamed on, I won't mention the country, but it was blamed on a particular country. But the ethical ramifications of that particular breach is even being felt today. And that malware stood in the software of multiple companies and multiple government agencies for almost a year before it was uncovered. So the amount of data that was collected was immense. And it was done through an upgrade, where you get a software update. And it was done in such a way that it would hide itself in the code looking like the original code. So it was very difficult to detect. The global impact of engineering ethics. Engineering decisions have global impacts, affecting not only local communities, but also international environments, economies, and societies. Ethical practices contribute to the well being of the planet and ensure responsible, sustainable development. Now, we talk about global warming as one issue. I am not informed well enough on global warming to give an opinion upon it, but those who are can give their informed opinions. But it leaves to them the responsibility to make sure they make right decisions regarding how the work that they're working on will impact the globe. Public health and safety in engineering is the most important issue regarding ethical engineering. The primary ethical obligation for all engineers is to protect the public health and safety. Every engineering decision must be made with well-being of the public in mind. Ethical practice ensures the safety and welfare of society are upheld. The role of professional organizations in ethics. Which professional organizations? Well, you got a number of them. I mentioned the NSPE, National Society of Professional Engineers, the NCEES, that's the National Council of Examiners for Engineers and Surveyors. They set guidelines for engineers to enforce standards professional behavior. So if I ask each of you, how many of you have read the Code of Conduct of the National Society of Professional Engineers? Let's raise hands. Well, I had to review it to go over this presentation. But I tell you, it's not something that I thought of in 55 years old. Let me go read that because I knew in my heart what I need to do. And I knew uh, from practical engineering what needs to be done. And I remember a time when a boss called me, and this is a high level boss. I was a real junior engineer, called me into the office and I had gone on a business trip. And he says to me, and first of all, no one gets called into his office unless you're in trouble. This was a high level office, and he was known as the quite a tough manager at that time. Managers like what you'd call a vice president today. And he says, "Sit down." I sit down. A week earlier, I'd gone on a business trip, and it was a type of business trip that was like it was given out as a perk. You were allowed to take your spouse and allowed to have her expenses covered by the company. So he says to me, I have your travel and entertainment voucher in front of me. And he put his hand on it, turned it around so I could read it, pushed it in front of me. It has some irregularities. And I had the chill of fear went up my spine and the hair on the back of my neck stood up. And I looked at the expense voucher and I said, it looks perfectly fine to me, though that's what I spent. And I thought he was going to say, well, you charged this and you should not have. But instead he said, fix it. It's too low. You're making everyone else look bad. And what this now, I did not take a course on ethics, but I knew from my background, my upbringing, I said, I cannot do that. I said, that's what I spent. And pushed it again in front of me and said, fix it. You're making everyone look bad. And I was afraid I'm going to lose my job. I'm a new engineer. And I said, I can't do that. He tried one more time and then he took it back. He said, go back to your office. 3 years, I did not go on another business trip. And he and I never crossed paths again. But it was a decision that had to be made. It was a decision that I had to make on the spot. And there was another decision further down the road that I will tell you about as a conflict of interest. And I would have lost my job had I not caved in. And I did not cave in. And fortunately, through the grace of God, I kept my job and all prevailed. And I'll explain that situation to you. In fact, maybe I ought to do it now. That I brought it up. I was in charge of maintenance. I was superintendent of maintenance. Now, I didn't want to present this as me. It was me. This was going to be a story for someone else, but I spilled the beans. I was superintendent of maintenance. And a week before, my boss had been demoted, and he was demoted because the union delegates and union personnel, very powerful union in the area we were working in, they had given him some wrong information, which resulted in an explosion. And they did that because he was trying to clean up the plant, get rid of all alcohol and drugs and things like that. And I was his direct report. He got demoted. I actually picked him up that morning. He didn't know he was demoted because he had been on vacation, brought him into the plant, and that's when he learned he was demoted. So that next Friday, that happened on a Monday, that next Friday, my boss comes in, which was my boss's boss, and said, the plant needs to come online on Monday. And that meant that I needed to have all of my maintenance workers out on Saturday working on overtime. So, and not all of them, I needed about 60 of them working on Saturday on overtime. So I said, okay, I'll arrange that. I made all the arrangements for that to happen. Union delegate walks in and says to me, hey, Steve, you got to get the plant online on Monday. I said, yeah, that's right. You need about 60 people working. And he says, well, guess what? We're not going to work unless you put down that we work an hour and a half every hour that we work. And I said, well, I can't do that. He says, well, then you're going to lose your job because if this plant doesn't come online on Monday, it's your job and you know it. See what we did to your boss? You're next. And this was in a work environment where I couldn't run to my boss it's my responsibility to get those maintenance workers out there. So I just stood my stand. I said, I can't do that. That's forging records. That's violating ethics of the company. It may not be your ethics, but it's mine. And what happened is it was 1 o'clock when the delegate came in to see me. And now it's 1:30. I'm getting quite nervous. At 2:30, I called my wife. I told her, honey, it looks like I'm going to get fired on Monday. So I seriously thought I was going to lose my job. Quitting time was 3 o'clock. And I'm watching the clock. And that was the minutes from 2:45 to 3 o'clock went like hours as I'm watching the clock and I'm saying, what am I going to do? What am I going to do? And at 2:57, my phone rings. I pick it up and it's one of the workers. And he says, Steve, I'll work tomorrow and I'll get paid for the hours I work. I said to the person, thank you. That's one person. Right after that, everybody agreed to work. And the whole workforce came in. They got paid their actual hours worked. They did get time and a half for the hours. Union delegate never brought it up again. But think about that dome I was standing on. I was standing on that slippery slope. And in my mind's eye, I was being fired on Monday. But if I had said yes to that step, that union delegate would have owned me for the next how many for the rest of my career. So professional organizations like the NSPE, NCEES set guidelines, but what really those guidelines are, those are what's written in word, and what you have to have is what's written on your heart. That's part of your ethical. That's part of what you makes an ethical person. What makes you an ethical person? The future of ethical engineering continues to evolve. The need for ethical practice will remain constant. There will always be need for ethical practice. Engineers must commit to upholding ethical standards, ensuring the safety and well-being of society, and addressing new ethical challenges posed by emerging technologies. One of the things you have to examine is your own biases. You may not even realize they're there, but don't forget you are a record of your past. You are for me, I am everything that's happened in these 50 years as an engineer is part of who I am today. And a lot of that is good, and there's some that is not so good. So I have to look back and say, and I've learned one of the things I learned early on was stop coming in and saying, okay, this is how we're going to do it. Now I say, tell me, how would you do this? And I listen to the group of engineers, and all of a sudden I realize, you know what? Here's an idea that's a lot better than mine. What made me think my idea was so great? And in doing that, it's respect for others. And it's a respect for others, regardless of their race, creed, or gender, or preferences, or even accents, because sometimes it's a lot easier for you as an engineer to listen to someone who's you can clearly understand and take their ideas. But some of our engineers are from different countries and have different accents, so it's difficult to listen to that engineer, and it's easy to tune that person out because of the difficulty in hearing. But if you listen, you will hear, and sometimes the ideas you hear will prosper your organization. And it's ethical to be given that person just as much hearing as the next. Professional Professionalism cannot exist without ethics. Every day you will make decisions. Every single day, the zero tolerance for unethical behavior needs to be a daily highest priority. Only you can make those decisions. I gotta make this small so I can read it. There it is. Professional obligations, NSPE Code of Ethics. That's what we're going to look at now. Engineers must adhere to professional obligations as outlined in the NSPE Code of Ethics, including honesty and integrity in all professional dealings, acknowledgement of errors and prompt correction of mistakes, avoidance of conflicts of interest. We're going to talk a couple of avoidance of conflict of interest cases. Sustainable development in engineering. Engineers must have a responsibility to design systems that meet the needs of the present without compromising future generations. Sustainable development includes minimizing environmental impact and conserving resources. Ethical responsibility in emerging fields. As new technologies such as AI, nanotechnology, and biotechnology emerge, engineers must apply ethical principles to address new challenges. These include issues of privacy, data security, and societal impacts of technological advances. When the coronavirus came out, who knows where it really came from? Was it from a laboratory? Was it from a bat? I don't know. I'm not informed accurately enough to have an opinion. But this is the type of thing that I would be really concerned about as an ethical engineer. And it's over 1 million people died in the United States alone. So it's one of those concerns, and it's still with us today. It's one of those concerns that you have to deal with when you're working in a field of bioengineering. ABET, that's the Accreditation Ethical Standards in Education. ABET stands for the Accreditation Board of Engineering and Technology. And back in as early as recently as 1999, ethics was not really required courses in engineering schools. So when did I get my degrees? I got a bachelor's in 72, a master's in 75, another master's in 78, worked on another master's until the school asked me to teach. And I said, "You mean I'm going to come here at night and you pay me instead of me pay you? Very good, we'll do that." So I stopped the nuclear engineering in 81 and started teaching at night while I was working days. But then I went back for my PhD and I got my PhD at night in 1998. So I was quite some time late in my career. Well, even up till 1998, ethics was not being taught as a requirement in engineering schools. ABET sets the standards for ethical standards for engineering programs, ensuring that students are prepared for the ethical challenges of professional practice. Programs must teach students to recognize and resolve ethical dilemmas. ABET criteria, ethical responsibility. ABET criteria focuses on ethical and professional responsibilities. Engineering students must learn to make informed judgments. Now, the word informed is important. You can't make judgments unless you've done your homework on the information. Like I have opinions about things, but if they are just opinions that are not based on research and data, I cannot make a judgment on those decisions and do that as a consultant and give a opinion to a client, unless I tell the client this is not an informed opinion, it's a gut feel. It's not an informed opinion. Uh, but that's why in my documentations I say, in my informed opinion, XYZ. So informed judgments that consider the impact of engineering solutions on society, environment, and public safety. ABET criteria, continuous improvement. One of the things you're doing right now is continuous improvement. ABET criteria ensures that engineering programs continuously assess and improve student outcomes in ethics. This promotes a culture of lifelong learning and adherence to ethical standards. Consider what you're doing right now. You are expanding your knowledge base for performing your profession properly. Future trends in engineering ethics. There's rapid advancement of technology presents new ethical challenges for engineers. As new materials come up, you need to make sure that those materials are in fact adequate. It raises the question. I think about that that deep sea sub that went down under the water and then collapsed under the pressure of the water. I'm not informed on to why and how it happened, but I understand that there were materials that were used on there that were supposed to be new type of materials that were should have withstood the pressure of the being under the ocean. They did not. So these include the ethical implications of AI, cybersecurity, and autonomous systems, which raise questions about responsibility, privacy, and accountability. Now, many of you probably have seen Odyssey 2001, where Hal decides not to let the astronaut back into the spaceship. Now, that was made in like 2000, at least 24 years ago. And at that time, the concept of having AI like we have today is not even, it was just scratching the surface. We're still scratching the surface today. But consider how much autonomy you give to a system of AI bots over a period of time. And when they get to be too autonomous and start to self-think, that's a tremendous responsibility to give to a bunch of electrons. And soon it'll be subatomic as we go into quantum computing, and it'll get even more powerful than many, many times more powerful than it is today. So think about when you give autonomy to robots. I'll give you an experiment that happened in AI. They taught robots, these little skating robots, to walk across a field and hit a ball. And the only thing that they taught the robot to do was to hit the ball into the net. So for weeks and days, they were hitting the ball into the net. All of a sudden, one robot decides to hit the ball to the robot that's nearest the net, who then hits the ball into the net. Where did that learning come from? The engineers, the IT engineers don't know. It was self-learned and how did it get there? They don't know. If you can't answer that question, how far can these robots get? And that's something we don't know. And the don't know is a very big ethical responsibility that we have to keep an eye on. And then where does that come into play? Well, think about that in defense systems, where you have national defense being a concern. And if you start putting autonomous systems in charge of war machines, it could get significant concerns about ethics could get into that. Technological advancements, AI and ethics, artificial intelligence presents significant ethical challenges such as enduring fairness and avoiding biases in AI algorithms. My AI algorithm has biases. It gives me, unless I tell it otherwise, only white men engineers. That's where it is right now. That will probably change, but it's a bias that's built in. It's one I've noticed. Now, maybe I'm wrong and it's not fully biased, but it's one that it's an observation I made. Protecting privacy of data and security in AI applications, very important. Watch what you ask AI because it goes into many places to get that information, and you want to make sure that you're not disclosing information from your clients to others. Cybersecurity and ethical challenges. Cybersecurity becomes more critical. Engineers must address the ethical issues involved in protecting data, ensuring privacy, and preventing cyber attacks. Ethical engineers must develop secure systems that safeguard the public. I am a private professional engineer, contracting consulting engineer. I go to many companies that have all kinds of layers of firewalls, et cetera, so that no one can get at their data. Then they give that data to me so that I can work on it and perform engineering on that data. Once they give that data to me, I have to treat that data with the same level of secrecy that they do, same level of of making sure that no one can hack into my computer. So sometimes I have to work offline so that my data is so that their data is kept secure. Global impact of engineering decisions. Engineering decisions have a global impact affecting international communities, economies, and the environment. Engineers must consider the ethical implications of their work and ensure that their projects benefit society at large. You know about the hydrogen economy, which is it's a tremendous effort taking place. I've done a number of projects on the development of hydrogen. It's going to be a very difficult, if at all possible, mode of energy consumption in the future, but it does have the potential for some significant change in emissions for equipment. Whether it'll be whether it'll be a true success or not is yet to be seen. But that's part of what you as ethical engineers have a responsibility to look at global impacts of your engineering work. Sustainability and environmental ethics. Now, I did a study on a lot of past engineering projects. Back in the day, when gas industry was making its own gas, it's called manufactured gas. They would take oils and blow steam on that oil, and gases would come off. And they'd take coke and heat that coke and blow water onto that, blow jet water onto that burning coke, and the gases that would come off would be CO2 and CH4. CH4 is methane. And they would send that out as what was then called town gas. It was about 55% methane, 45% CO and CO2, but a lot of CO. That's why back in the day, before the 1950s, people could commit suicide by putting their head in the oven. There was so much carbon monoxide in that gas. Well, those coal plants, those gas plants, I should call them, they used to dump a lot of what's in the ground today, what is environmentally unsafe, carcinogens, etc. Many of those sites today are Superfunds sites that have to be cleaned up, and that was because of poor engineering at that time. Today, we would never dump those materials in the grounds. Uh, think about Love Canal. Love Canal was a place where they buried a lot of carcinogenic materials. And for years, women in that area were having miscarriages, deformed children. A lot of cancers were cropping up amongst the people who lived there. These contaminants got into the water table, and eventually they had to shut down that entire area. And that was when the Superfund sites. That was when Superfunds became a a governmental uh, resource. Again, they started a new program. They called it the Superfund, and they made these sites for Superfund cleanup. Case study, the challenge of disaster. Unfortunately, I kind of mentioned this earlier because it's such a clear a challenge. The challenge of disaster is a powerful example of the consequences of ignoring ethical responsibilities. Engineers must learn from this case and prioritize public safety over external pressures to meet deadlines and budget constraints. What happened was NASA was behind schedule, NASA was over budget, NASA was like not looking good to their higher ups, and there was a lot of pressure. You must launch. Well, this slide shows the crew from the Challenger is asked to emphasize the importance of reporting known risk and prioritizing public safety over external pressure. The lessons learned from this case are critical for ensuring future ethical decision making. The engineers knew that the O-rings were at risk at this cold weather, and the temperature was below their threshold for when they should launch using these O-rings, this O-ring design. The engineer said, no, you shouldn't launch. The engineering manager, the chief engineer, says, no, we should not launch. The higher ups in management said to to the chief engineer, take off your engineering hat, put on your management hat. We need to launch. The chief engineer reluctantly agreed, and they launched. 76 seconds later, these 7 people were dead or in the process of dying. This case study is one that's really, I find extremely interesting. This is the case study of the Hyatt Review, the walkway collapse. And the reason why I find this one interesting is because in all of the plant commissionings that I've been involved in, there are often many, many changes that are made to the original design, but every one of them needs to be MOC'd. MOC stands for Management of Change Reviewed, which means it has to go through a whole engineering analysis to make sure that change is proper. One of them I can think of is a level gauge that they were using. They were using radar level gauge for a certain vessel, and the radar was not working properly with that fluid. So they switched from a radar gauge to 2 pressure taps, one on the bottom, one on the top. You look at the differential pressure between that, and from that you can deduce the height of the liquid within the column. But in order to do that, you also need to know the density of the liquid. So you need multiple densometers. And so the reason why I say multiple densometers, because what if one of those transducers gives you a wrong reading? What you typically do when you do this type of a reading is you put three sets of transmitters or pressure sensors, 3 sets of densometers, and then you get 3 separate readings. And if one of them is out of whack, you can say that one's out of whack because the other 2 combined. So it goes through a voting system, and 2 out of 3 will tell you what the correct reading is. You have to get that third one. It has to have maintenance to get it improved. So what happened with the Hyatt collapse? Well, take a look here. I made the sketch up. Take a look here, and you can see the original design. It was to have this rod come down, hold up multiple platforms. And then you put the first platform on and you screw the washer and nut all the way up to the top. And you put that here. Then you put the next platform and you screw the washer and nut all the way up to here. Then you put your last platform and screw the nut and washer all the way up to here. I don't know how many platforms there were. I believe there were more than 3, but I just drew 3 for example. So somebody thought up a great idea to how to save mechanical work. He said, just cut the rods, put your first one on, cut the rod, put your second one on, cut the rod, put your third one on. You don't have to wait. And there were hundreds of these rods when you went and looked all around the internal stack walkways within the Hyatt Hotel. So what happened is you save a little bit of time here, multiply that by the hundreds of connections, you save a lot of time. Maybe they even gave that guy a work sim and sent him away to a perk as a work improvement. But what they did was they caused a potential, which ended up being an actual failure. Because now, why would this fail? The rods are still holding. This rod is still holding three balconies, as this rod is holding 3 balconies. This rod is still holding 2 balconies, as this rod is still holding 2 balconies. What failed was the connection right here. This flange is seeing right now, when I point to this flange, it's seeing the force of 1 balcony. This flange right here is seeing the force of 3 balconies, 3 times what it was designed for. The opening in the flange fish mouth and the washer and nut pulled right through the walkway, and all the walkways fell. Now, what could have also failed would have been the threads on the nut. There are so many things that could have failed here, but the force on this nut was, in this case, as I've drawn it tripled. If there were four staircases, it would have been quadrupled. What was the end result? The Hyatt Walkway collapse case demonstrates that changes in the field during construction can have severe consequences. All professional engineers should ensure that management change program is incorporated into their projects. A design modification was made and installed without a proper technical engineering review. The result, 114 people died. These are 114 people who will not have however many children followed them. So it's not only 114 people died, their next generation that has not come about yet, they died as well. And the future of all the people that would have come from these 114 people died with them. But whenever a person dies, and I've had people die that were close friends that were work colleagues. In fact, my boss died on a job, and his was a job that he was working, and I had asked him that day to go stop in at one of my jobs. It was a Sunday job. I asked him, could you stop in? I had a pressure test going and just check the pressure. I want to make sure I wasn't getting any loss of pressure on my pressure test. And so that afternoon, I called his house, and his wife was frantic. And his wife says to me, Steve, there's been an accident. I've heard it on the radio. I can't get a hold of Frank. I said, don't worry about it. I shouldn't say the name. I'm sorry. I said, don't worry about it. I will go down to the job. I'll have him call you. I went down to the job. Frank was in the hospital. One person was killed and five people were injured. You know what caused that accident? Lack of using lockout tagout. That was one of the contributing causes, I should say, multiple causes, but that was the key. And that's a failure on the part of the engineers who were overseeing that job to assure lockout and tag out and all of the other tree of failures that came up would not have been would not have occurred. There's something called the Swiss cheese layer of protection analysis. And it's called Swiss cheese. It's because you build in layers of protection. And it's like if you put down a piece of cheese, Swiss cheese, it's got a hole in it. Put down another piece of cheese, it's got that hole covered, the first hole, but it's got other holes. Put down another piece of Swiss cheese, and it covers that. And all jobs are built with layers of protection. And every so often, all those holes will just by chance happen to line up, and an accident can happen. So it's up to the engineers to review the jobs that they're putting out to make sure they don't have those holes line up and that the layers of protection are proper. In this case, the Hyatt Hotel, what was missing is that management of change review. In the case of my boss, and he was a close friend, it was the lack of lockout tagout and other things that happened on that job. The Pinto case, it's a case study. Ford Pinto had a design whereby their gas tanks were prone to being exploding, were prone to leakage in the event they had a vehicle accident. And that was ignored by management. The engineers brought it up and it was ignored by management. So the engineers eventually did. And I believe the number was about 20 cases where people got killed as these gas tanks blew up. Uh, the engineers from Ford went outside the company, made it public. And once they did that, Ralph Nader got involved. And this case underscores the importance of whistleblowing. Now, nobody likes to be a snitch or a whistleblower, but where it comes to being a professional engineer, protecting public safety, you as a professional engineer are required to whistleblow if your company is not taking care of the public and hiding things have known consequence. Case study review, the Deepwater Horizon. There's another case study. Yeah, we all remember it. It was the worst environmental hazard, or environmental not hazard, but environmental event that's known to man, other than now we have thermonuclear tests that had taken place. So, but this is the worst environmental disaster of an accident that has occurred. The engineers knew that their safety protocols were being ignored. This was a preventable accident, extensively destroyed marine life habitats, beaches, and local economies. It instilled a mistrust of the oil industry in the public. Even till today, there's a mistrust of the oil industry. A lot was caused the by Exxon Valdez and by Deepwater Horizon. So the negative of this was more environmental than it was death to employees or the public. But it also destroyed economies. A lot of people lost their jobs, and beaches are still affected today by what happened with this Deepwater Horizon. The future of ethical engineering. As engineering continues to evolve, the need for ethical practice will remain a constant. Engineers must commit to upholding ethical standards, ensuring the safety and well-being of society, and addressing new ethical challenges posed by emerging technologies. One of the things I can say to you as people who are of my vintage, this is old, but of my vintage, if you're a lead engineer or you are a seasoned engineer, your responsibility is to train the way they should grow up. It reminds me of a verse that says, train your children in the way they should grow, and when they are old, they will not depart from it. It has nothing to do with engineering, that verse. But the same is holds true. You as a manager of young engineers that are coming into the workforce, your responsibility is to train them up as they should go, which is by following ethical standards. When the boss called me in and told me to change my travel and entertainment voucher, he was not being an ethical engineer. And he was a professional engineer as well, but he was not being an ethical engineer. So when you're in that position of being the ethical engineer with other engineers reporting to you, keep this in mind because it's your responsibility to train them up as they should go. And when they get older, take your position, they will not deviate from that path. Conclusions. Ethical practice in engineering. Ethical practice is essential to the integrity and trust of engineering profession. Engineers must prioritize health and safety, adhere to ethical standards, and continuously engage in professional development to address new challenges. Ethical engineering practices include